Live from New York, it's Ask This Engineer.
Hey everybody, and welcome to another wonderful and magical world of engineering.
That's right.
Featuring me, Lady Ada, not Minnie Mouse, and Mr. Lady Ada, not Mickey Mouse.
No.
But it's pretty much like a wonderful world of Disney, but it's of engineering.
Yeah. I like to call it the wonderful world of making.
That's true.
Yeah.
I think, did you do a video once about that?
I tried to, yeah.
Yeah, okay.
I wanted to have this thing where you would like be flying through a hacker space and be the wonderful world of making and yeah. But this is kind of like that.
All right, well, close enough. I'm the engineer, and you're stuck with me. And we're here at Adafruit downtown Manhattan, and we're broadcasting to you live. So this is actually happening. So all of our clumsiness is as you see it. We'll have live demos later, which I hope will work out. We got an exciting show for you tonight, a full hour of engineering joy. So let's get started.
This is a huge show. On tonight's show, the code is Flora, 10% off in the Adafruit store all the way up to 11:59 p.m. Eastern Standard Time tonight. It'll be pretty obvious why the code is Flora soon. Talk about show and tell, people from around the world showing and sharing their projects, hacker spaces, maker spaces, retro stuff and more on the show and tell. Pack the Mailbag's going to stop by. We'll stop by the Adafruit Jobs Board. Some news in the world of open source hardware. Some announcements in Arduino world. Adafruit Learning System, we have way too many tutorials to go over, but we are going to attempt to get through them anyways. Show you some of the newest guides on the site. Time travel, look back in maker history, science history, you name it. If it's happened and it's cool, it's about learning or math or something, we probably have a post about it now. Wearables, got a video. 3D printing, got a video. We've got a special video, Colin's Lab, new one just came out. Oh my gosh, oh my gosh, oh my gosh, oh my gosh. We've got a ton of new products.
Everybody get excited.
We're answering your questions. We're going to have a trivia question. All that and more on, you guessed it, Ask an Engineer. All right, there's a lot of stuff going on tonight.
We have such a jam-packed show. We can't even stop. We have to immediately.
We're just going to keep going. So first up, let's pay some bills. The code's Flora, 10% off in the Adafruit store. Don't forget, we're still taking Bitcoins. We are still taking Bitcoins.
You just like saying that.
Yeah, and we also have the deal, $200 or more, UPS ground, continental US. This week's show, brought to you by a specific letter of the alphabet. Lady Ada, we've been going through this every week for multiple weeks now. You have a coloring book. It's a new one called Lady Ada's R is for Robot. So every week the show is brought to you by a letter of the alphabet. We are up to the letter P. And P is for prosthetic. And this is an interesting one because people will see this in the coloring book. They can download it or they can get it from Adafruit. And
you know what P is also for?
What?
Paluska.
Paluska. And what's interesting about this particular one, it's one of my favorite wired covers. I have a couple of favorite ones.
Okay.
I've seen one that I really like. But this is one of
the
my
one with Paluska, no?
The one with you on it. But this is from Dan Paluska, and we know him. This was a very well-known wired cover, and he was an MIT student. And he really has the rest of his body. This is just.
He works in the leg lab, and they just composited him.
And he is one of the most talented roboticists, and then later went on to do this very cool musical instrument thing. But we put it in there because it was like the first time that people got what prosthetics might look like with robotics, and he was so ahead of everybody on what he was doing. So, anyways, this week's letter, P is for prosthetics.
For Paluska Prosthetics.
And it's brought to you by Lady Ada's coloring book, R is for Robots. And just a reminder, everyone,
make robot friends,
not robot enemy.
Okay.
Trust me on this one.
We should probably just keep posting this every day.
I've seen what's coming up. Robot friend, not robot enemy. Okay. So show and tell happens every week, Lady Ada, 7:30 p.m. Eastern Standard Time. People from around the world show their stuff. What was on the show this week?
Yes, I wrote it all down. We had a fun show tonight. We had a lot of people show up, but it kind of went nice and smooth and even. So it wasn't like 50,000 people all showed up at once. So that was really good. So we had some new people and some repeats. Start off with Adafruit favorite Tony DeCola from Adafruit Northwest, who has been working on, he wrote a tutorial on using the ESP8266 module, which is a low-cost Wi-Fi module, with MicroPython. So he did a tutorial on porting he didn't do the port, but compiling a port of MicroPython, which is a miniature version of the Python programming language, to this Wi-Fi module. So you can actually program this module with Python. There's a tutorial on the learning system, so check it out, and we'll even probably mention it later. You can't save your files yet, so you just write the code and it runs right then, but it's good for playing around with if you just want to mess around with MicroPython. And he showed an LED blinking. Noe and Pedro from Adafruit Southeast also came by. They were showing off two new projects that they've been working on. One is an Apple Watch charger. They made a portable charger.
Maybe one of the first portable Apple Watch chargers.
One of the first, yeah. It said it's a remix. And that's cool. We're into open source. It's a remix. It's on Thingiverse, and you can remix it too. But he wanted to travel, and so they made a PowerBoost 1000C plus one of our LiPo batteries, and then they cut the Apple Watch charger and threaded it through to make it so that it's like a little portable thing that you can.
And you can charge it. You can charge the watch.
You can charge it and
charge the thing at the same time. Very cool. And has a little mustache on it.
But it's basically designed specifically for charging your watch. I guess you also charge the Moto 360. So check out that tutorial. They also made a NeoPixel arcade button tutorial, which is like I predict this is going to be super popular, and there's going to be a lot of derivatives. A 3D printed piece that goes in an arcade button and makes it so you can put a NeoPixel in it without any cutting or drilling. And they have a really big project tomorrow, so check out 3D Thursday, tomorrow, Thursday, 3 p.m. Okay. Next up, Phil B. came by with a quickie project that is just, I think it's the best project ever. He took the NeoPixel goggles, and then he made an infinity mirror version, so it looks like the LEDs are going into his skull, and it looks super cool. And then he added a Bluefruit low energy module, and he made it like Bluetooth low energy controlled. We'll actually demo basically the same thing later on in the show, so stick around. Don't step out. But check out that video for these freaking awesome goggles. He's going to be walking around Maker Faire with them. So if you're going to Maker Faire this weekend, look for Phil B wearing these goggles and tell him what a great job he's doing. And Richard came in and showed off on his mobile phone a workshop with a CNC mill. He has his local makerspace as a really gigantic wooden CNC mill. Ben, who's been working on this big rabbit head cosplay project, is now working on making his own 3D printer that's very big, so he can 3D print his own cosplay props, like helmets and like arms and like all sorts of cool stuff for like cosplay and costuming. So check that out if you're interested in making ginormous 3D printers. Drew, which inspired the Mickey Mouse joke earlier, is going to 24 Hours of Disney. I guess it's some event. Yeah. And he got the Mickey Mouse hat because I guess he went to Disney World or he bought one, and he fitted it out with NeoPixels and a Flora, and it like just has this cool light effect, and like it's just the coolest Mickey Mouse hat ever. So check that out. And he made two, one for him and one for his partner, and they're gonna go be the Electric Light Parade. Roberto stepped in for just a few seconds and showed off a DIY handy tool that his son made using a plank of wood and then two of these like air hose things with clips on the end. Basically, he made his own. We have one in the store, but like, you don't have to buy one. You can make your own from stuff you have and a local hardware store. And then Kirby just had two cats.
Totally okay.
And that's it. It was just two cats. But Kirby also can get a sticker because you get a sticker and put it on the cat, and they do this weird thing where they're like, like why is there a sticker on me? And they kind of freak out. Putting tape on cats is like one of my favorite hobbies.
Okay. All right.
Don't tell the ASPCA.
All participants on the show and tell get SE on the show and tell sticker. Just email support@adafruit.com. We'll send one out to you. Lady Ada, how do people get on the show and tell?
If you would like to show off your project on next week's show and tell, super easy. Just go to our Google Plus page at plus.google.com/plus Adafruit and look for the thread with the AdaBot that's saying, hey, comment here to get added to the show and tell circle. And then you comment there, we'll click on your avatar and add you to the show and tell circle, and you'll join the other 600 people who are in our show and tell circle. FYI, Google doesn't seem to dig having so many people in the circle, so when we send out invites, it might take a while. So just please, like, we do send them to everybody. It just might take a few minutes, but we do send them. Yeah. So please put yourself in the circle, and you'll get an invite every week, 7:30 p.m. Eastern Time. Okay.
All right. Pack the mailbag, stops by. We get these letters every single week. We do a all-company meeting every week, and we read these too. So when you guys send emails to us, and they're nice emails, we read them to everybody. Most of the emails are nice anyway, so we're very lucky. This one's from Neil. I placed an order from the company I work for, Boeing, and I wanted to pass a note from the person who receives and processes our packages. She said that your box was fantastic to open and go through. Everything was neatly arranged and packed tightly. According to her, you could have put a bow on it and it would have been a Christmas gift to her. So thanks so much for making someone's day a little brighter.
All
Now,
right.
this is the funny thing. So people take photos of when they open up our boxes, but how well we pack everything.
Yeah.
And they send it to us, and they tweet it and everything. And it's
It's mostly Elisa.
well, it's in the entire team at Adafruit.
I know, but
the entire
Elisa
team.
is just like,
it's
she
the entire
loves
team
to-
in Adafruit.
Jeez.
And one of the cool things, and the reason I like that is because it could go the other way. If we did really crummy packaging, like Twitter's basically used to complain. As far as I could tell, it's to
Complain to United,
complain just to complain.
the airlines.
Yeah, it's fine. Like everything has a purpose. So it also could be used for other things. So people will email us and send us this stuff, and people who do shipping really appreciate it. And when we were in an apartment, and it was just like you and I, when I would unpack the DigiKey boxes, I always was like, boy, these invoices. I wish there was like pictures and there was like quotes or something. So we did that with our invoices. So when you do shipping, I think
Thus,
you're
invoice.
yeah, we called it invoice. Anyways.
Invoice. Innovation in invoices.
Okay, so we got some other news. Every month, we go to the bookstore and we look at what's on the cover of magazines. And now I have like a third or fourth favorite magazine Wired cover that I like. Congratulations, Megan Smith, CTO of America, and she was on the cover of Wired. Another UMIT lady.
She's an MIT engineer. She's
MIT
now the second female engineer, also
Yeah.
from MIT, on the cover of Wired.
Your UMIT lady engineers are taking over.
Yeah.
So good work.
And Paliska, I mean, like, he's not a woman, but he's also an MIT engineer. So it's like
Yeah,
now there's
he-
three MIT
half-
engineers.
He was the first half robot man.
Half robot,
to
that's
be
true.
on the cover of Wired. So, anyways, one of the things we like to say what we celebrate. If you see more people like Megan or Lady Ada on a magazine, I think young girls in particular can say, I want to be like that. I want to grow up and do something like that. I want to read more about this person. Because previous months when we take photos of the magazine aisle, it's pretty dismal. There's not as many reality TV show stars anymore. That's getting good. So anyways, working on that.
Maybe we're reading
okay.
through it.
Help wanted. This is the Adafruit jobs board. This is where makers can post their skills and companies can post their jobs. And we have a pretty good success rate. This is a nice job. So if you ever wanted to work for DeWalt at Stanley Black & Decker, you can. This is a hand-on position for a small group of engineers dedicated to developing advanced motor control solutions for professional and consumer power tools. Wow.
Neat.
So this is like if you wanted to make power tools, you need to know some PCB design, some I2C, some
Analog,
SPI, UART.
digital,
Yeah.
power, it's circuit simulation,
Yeah.
stack-up tolerance.
DeWalt Professional Power Tools is looking for someone with maker skills. So this is kind of neat because if you ever wanted to make something that you knew might be in the hands of lots of people, this would be the way to do it. And also, with all the technologies coming down in price, eventually, like I have a pretty nice set of tools. It would be nice if my drill told me more. Like maybe it could tell me when one of the batteries needs to be recharged or something a little bit smarter than
I have
just.
seen I'm seeing like tools where like not only multimeters obviously, but like I was looking at, I don't remember which company it was, but they had like moisture meters and like RF meters, and it was all
Yeah.
like it was like a off the shelf. I don't remember the name. It was like maybe it was in Milwaukee or something, but they had it's like cell phone interactivity. Like you could record
Yeah.
your readings directly. Like I think it was like a moisture sensor and also like maybe like a metal sensor
Yeah.
and like
Also-
a distance sensor.
Yeah.
A distance sensor, and like you would laser distance to the wall, but it would save it on your phone.
Also, simple things like if my drill leaves where it normally is, like farther away, like it should like beep or do something
Yeah,
because
it should
it's
be
my
like,
drill.
bring my drill
Yeah,
back.
just bring my drill
That
back.
would actually solve 90% of power tool problems.
Yeah. Okay.
Where is it?
All right. Some news in the world of open source hardware. Okay. First up, big ups. I think that I'd like to give out to Autodesk for continuing to release more and more. So the Ember Spark printer,
Yeah.
they released all the mechanical designs
Oh.
under Creative Commons.
That's
So
cool.
Eric Wilhelm, who's a friend of ours, who is one of the co-founders of Instructables, is the one who posted about this, and they're putting up all the designs. So that's a big deal.
Huh,
Big
neat.
deal. Next up, other news in the maker movement. Congratulations, Jenny Lawton. She's now the chief strategy officer of Littlebits. Jenny, former CEO of MakerBot.
And then
So-
previously also president.
and
She was
pr-
president and then CEO.
Yeah. So stay tuned because anytime they have these like heavy hitters and these like really
Things are getting serious.
things are getting serious, the maker movement is happening. It is happening.
No, this is like getting
This is
mainstream.
happening. So anyways, congratulations, Jenny, and congratulations to Littlebits. looking forward to seeing what you guys are up to. Next up, some Arduino news. That's right. This week, big announcement from Samsung. Now, I gotta say, there was a CES keynote, and
this was last January.
This is last January, and the CEO or president of Samsung said, "We're going to do IoT, Internet of Things, and we're going to do it. We're going to be open." So I took screenshots. I'm like, "Oh boy, here it comes. They're going to say it, and I'm going to have to later they're going to change their mind." But you know what? They're actually going on a pretty good trajectory. Okay. They made this announcement with Arduino, and it's called Arctic. And basically, Arctic. I'll read the quote here. From Massimo, the co-founder of Arduino. "Millions of developers and makers now rely on open platforms and easy-to-access technologies to bring their work to life. We're excited to make Arctic fully Arduino compatible, which will give our community the tools to create something revolutionary in IoT." This is a week after the Microsoft announcement, and so these are the boards. And you have opinions about these. So basically, what are these little boards?
Well, I'll be honest, I actually don't know the details of what they are because this is all we've got. But it looks like these are, they're decaps.
Yeah, I shouldn't say opinions. You're aware of what they,
the capabilities. I can kind of see what's going on here. I mean, there's 3 different modules. Samsung probably doesn't make the chipsets. They probably just cleaned them off. They're probably like Cortex or like NXP or Freescale processors or something like that. Looks like there's an ARM Mali-based and a 8-core processor as well, and these are capped usually, so you would pick and place them onto your product. There's pads underneath that would allow you to basically drop in this smart brain. And there's a teeny one. There's a 1/2 inch by 1/2 inch, and it's actually pretty hardcore. It's 250 megahertz dual core, and then they go up to from there to 1 gigahertz. This is kind of similar to the Edison. That's kind of the closest thing. I mean, they're clearly all going to be. I think that Arctic 5 and 10 are definitely running Linux because if it's an ARM based, it's going to be Linux something. I don't know what it is. Going to be Android or something or Umlaut. What's the name of the other Angstrom? Yeah. I always think of the little circle with an umlaut. Probably one of those. On the Arctic One, it might be Linux, or it might be a micro Linux, or it might be an embedded processor. But we'll see later once we actually get a hand on it. I think that I don't think it's a Samsung processor, but it's probably just something that uses their cell phone or Wi-Fi stack.
Yeah, what I want to do is get one of these Arctics and have it do Internet of Things like tweets or emails or SMSs about our Samsung pick-and-place machines that we have. Yeah. Anyways, so in other
Samsung Big and Samsung Teeny.
Yeah, and what would be neat is maybe we can make an Arctic board or something on our Samsungs. That'd be cool. Yeah, Samsung making Samsungs.
Samsung sandwich.
Yeah. So we also have another. This is a really big deal. So Colin's Lab, we do these videos. This is something I've worked with Colin for years on this Colin Labs thing together with him, and you kind of just unleash Colin. He just does his thing.
He's like a cheetah.
Yeah. So now we're really happy about this because it seems like a good time to do this. We have a full video about, and this will help so many people. What is an Arduino?
What is an Arduino?
And so here it is. It's about 7 minutes. So get comfy, folks. This is Colin's Lab. Premiere live on Ask an Engineer.
Arduino microcontroller boards are the go-to option for most basic digital electronics projects. They're easy to use and used by many. But what is a microcontroller, you might ask? A microcontroller is like a very basic computer on a chip. You upload programs to it, and it runs that program code over and over in a loop. This code can control the microcontroller pins by powering them on or off, or detecting whether a positive or negative charge is connected to them. The chip itself uses additional external components to provide timing, USB, and power support. The Arduino includes all of these things on a single board along with rows of socket headers, which are connected to the microcontroller pins, making it easy to get your project up and running quickly. There are many flavors of Arduino available, but when you're just getting started, go with an Arduino Uno. This is the most vanilla model available and should cover most common project requirements. One important element, which can't be included on the board, is the software used to write Arduino code. We of course run that on our computer. basic Arduino program, or sketch, consists of two parts, the setup and the loop. The setup section includes code we want to run only once when the board first starts up, and the loop contains code that we want to run again and again, forever, in a loop. So for example, let's say I want to flash an LED connected to pin 3. In the setup, I'll tell the Arduino to set the pin we're using to output mode so it can provide power to the LED. Then in the loop, I'll turn the power for that pin on, or high. Tell the Arduino to wait for, let's say, half a second, and then turn the power pin off, or low, and then wait for another half second. Once this code is finished running and the Arduino reaches the end of the loop, it will return to the beginning and run all the code over again, and again, and again. So if we upload the sketch to our board, we can see it doing just what we told it to. The LED powers on for half a second, then goes dark for another half second, and repeats. So that's an example of using a pin in output mode. But what about input? The simplest form of input hardware is a momentary push button. I'll connect one side of this button to the 5-volt pin and the other side to pin 7. Now in my code, I'll set pin 7 to input mode in the setup. And in the loop, I'll check to see if pin 7 is high or connected to positive voltage. And if it is, I'll light the LED by setting the LED pin high. If it's not, I'll set the LED low. When the button is pushed, a connection is made between pin 7 and 5 volts. So far, we've been using what's called digital input. This means the Arduino checks to see if there is or isn't a positive charge present at a pin. But there's also another type, analog input. Analog input measures the amount of voltage present at a pin. And because it's a special function, only several pins can actually use it. We can create a variable voltage input by hooking up a small potentiometer. One side of the potentiometer connects to power and the other to ground, while the middle lead connects to analog pin 0. Now, I could alter my code to light the LED once the potentiometer is turned past a certain point, but that's a little boring, no? Luckily, the Arduino can simulate analog output, which gives us the ability to dim the LED in response to readings from the potentiometer. So in my code, I'll read the analog value from the potentiometer and then turn around and send it right back out to the LED. So you see, the strength of Arduino is that each little part and concept can be adapted to new and interesting components, sensors, even motors. And this is made even easier through the use of Arduino libraries. Now, libraries are collections of pre-written code that allow you to perform complex operations simply. For example, controlling a servo motor. While I could spend hours learning how they work and writing the code for an Arduino to control it, it's much faster to include the Arduino servo library instead. So now, with only a few changes, I can convert the potentiometer's position into motorized motion. In addition to all the individual components you can use with an Arduino, there are add-on boards called shields. Shields are sort of like the hardware equivalent of libraries. Shields provide specialized functionality via a pre-designed circuit board that mounts right on top of the Arduino. There are shields for sound playback, controlling motors, LCD displays, LED matrices, GPS, many different uses. All this variety of hardware, example code, libraries, and the huge community of people who use Arduino means that it's really easy to do pretty much anything electronic with one of these little boards. So if someone asks, what can I do with an Arduino? I suppose the best response would be, what do you want to do?
Alrighty, and that was Colin's lab. Okay.
What a great video.
So now when anyone says, what's an Arduino, you can point to that.
Look at this lovely video with
Okay.
a beautiful Arduino.
Yeah. Okay.
Perfect teal.
Next up, Adafruit Learning System. Lady
Speed
Ada,
round.
we're going to do speed round
Speed
because
round.
you have 780 tutorials right now. 780 tutorials right now.
Yeah,
Actually,
that's
maybe
too
there's
many.
one more. Okay.
781, I think.
Yeah, okay. So, speed round.
Okay.
I'll help out. This is Torbeck's desk. We're going to do a video of this shortly.
Okay, so stay tuned.
Next up.
This is using a BeagleBone Black with some of our RGB matrices, the 64x64, 32x32, and make a 64x64 grid, and play arcade games on it. It's just a fun little DIY arcade game using BeagleBone Black and some code with the RGB matrices. I mean, look at it. It's like glowy. Check it out.
Next up.
This is a project I talked about earlier. Noah and Pedro made 3D printed fittings that can go inside a NeoPixel button to turn it into a NeoPixel, it goes into an arcade button to turn it into a NeoPixel arcade button, so you can have like a working arcade button that's also rainbowy.
Okay, next.
This is actually from last week, because we didn't get to go through the tutorials last week. This is Brandon's tutorial where he has been outfitting his home with intelligent mouse traps for intelligent mice. And he's using Adafruit I/O to track and keep track of mouse activity. And he has these traps that have a tip sensor and then a magnetic sensor, and it goes into a Raspberry Pi and it logs to Adafruit I/O. So it's a fun demo of Adafruit I/O and using a Raspberry Pi to vermin trap.
Okay, next.
Trap. This is a demo from Mike Borella using the ESP8266. You can use this with either the older little module or our nice Huzzah module, which is recommended because it's a little easier to use. And this is just a simple humidity temperature sensor web server, just basic demo using the ESP8266 module.
Okay, there's more.
We had also released last week the Bluefruit Low Energy UART friend. This is our next generation of Bluetooth Low Energy. We had the NRF 8001, but now we're moving to the next generation NRF 51822. We have these lovely 32K modules. They're FCC and CE certified. We have awesome firmware. They work great. This is a little UART version that has flow control, and we have a lot of example code. It works with our app. If you want to add Bluetooth to something, Bluetooth Low Energy, you want to check this out because this is going to be the best way to do it.
Okay, there's more. You're like halfway through.
I'm not even done. This is a demo that Tony DeCola talked about in the show and tell, compiling and running MicroPython on the ESP8266. You can actually write Python on this Wi-Fi module. Wi-Fi works. You can do pin input output stuff. Really fun if you want to if you know Python and you want to try using that instead of Lua or Arduino on these little $2 Wi-Fi chips.
Okay, there's more.
This is a Noah and Pedro project. Noah and Pedro, I don't remember who, I think Pedro got a Apple Watch, or maybe they've got two, one of each of them.
Right.
They made a portable Apple Watch charger. So they took the key charger and 3D printed a case with PowerBoost 1000C and a nice 2000 milliamp hour battery, so you can get basically 2 weeks worth of charge time portably. So if you're traveling a lot or you just want to have a backup charger for your Apple Watch, it just shows you how to design that.
Okay.
3D printed.
There's more.
I'm not done. If you like the Bluefruit Low Energy we just talked about that plugs into a breadboard, and you have a wearable project, you'll probably really dig the new Flora Bluefruit LE. It's a new product. We'll talk about it later. But it's basically a sewable version of the Bluetooth Low Energy and allows you to add Bluetooth LE to all of your wearable projects. Also, it's nice and round, maybe good for some people who don't want a square PCB.
Okay, there's still more.
This is a project that we did in-house with James DeVito. He makes a lot of prototypes for me. Like here, he's building the future PhoneShield that's going to come out soon, and he makes these prototypes. And he has a pneumatic paste dispenser, and he connected up one of the little syringes that we use for paste deposition. But it's really annoying because there's a foot switch, and actually your foot gets tired, and it's also not as precise. So he 3D printed a thing that fits over the syringe, and then attached a button, and then brought that out with a connector to the pneumatic paste dispenser. Yeah. So he just presses the button, and it's just like the most elegant paste dispensing system.
It's super nice.
Very fancy.
Next up, I'll do this one. How to create wish lists and quotes on Adafruit. We revamped our entire wish list system. You have public wish lists and more. This shows you how to do it. Next up, I'll actually do this one. This is an update. This is adding third-party support to the Arduino IDE 1.6.4. This is from Todd. And it has all the latest things that just went into the IDE. There we have a little video that has a tour. Basically, my favorite parts, the Gemma's now in there, Arduino Gemma. And then you can, with just a URL cut and paste, and put in the Adafruit boards, and it just downloads in. And you also have access to all our libraries. So we have a tutorial on that. Super easy. This is one that you guys will be seeing soon. This is the animatronic servo tail. This uses... It
has the cutest little GIF. The tail goes back and forth. It's just a simple trinket, micro servo 3D printing project. So you can make a little thing that clips onto your belt, and the tail just wags back and forth. Just a little bit of math. And it looks very cute, very straightforward and simple. It's a good project for beginner cosplayers.
And then this is the tutorial you were talking about earlier. It's from Phil B. It's a Bluetooth-controlled NeoPixel goggles. He showed these off on the show and tell tonight. If you want to build these, you can.
Again, it's got an infinity mirror, plus Bluetooth energy, plus it's like the fanciest NeoPixel goggles. I kind of want a pair now.
Yeah.
Yeah, he had the pixels string around the edge, and then there's like the reflection stuff.
Yeah. Okay.
Yeah, that's nice.
All right, time travel. I'm just going to do one quick one. Some news, history, and more in the world of makers. This is the anniversary of Mary Keyes. She became the first woman awarded a U.S. patent for a technique of wearing straw with silk and thread. Straw weaving was an economically vital industry during America in the 1800s, and she was the first one, and she got a patent on May 5th, 1809. I'm doing this one a week later because we had a guest on the show last week. Her patent was signed by President James Madison, so that's cool. All right, next up, Wearables this week. We've got a video. A lot of people, when they ask Becky, who's our director of wearable electronics, you seem so organized. You have all this stuff. She did a video tour of her desk, and
it's right behind us.
Yeah, this is the video.
You can pretend like you're here.
Everybody, recently we moved my desk and the whole wearables department over into this new zone, so I thought I'd give you a tour. First is this shelving unit here. It's got my favorite fabric steamer, some photo equipment, tripods, and glass that I shoot on, my makeup kit, and some archive projects way up there. Over here is my video light that I use to shoot my projects, and it's my shooting spot right here. You can see I'm shooting some B-roll for this project with my Manfrotto magic arm that I like a lot.
One of my favorite things about my desk is my louvered bin panel with all of these bins full of delicious components.
And some component drawers. You can see that I really like my label maker. And then behind me is the rack of projects you might recognize as the backdrop for the live show. It's really good for organizing all of our hanging up projects as well as whatever will go in this bin.
Here we have plenty of light so my plants get a lot of love. Can't keep these alive at home. Here's my cabinet of flammables. What's your favorite solvent?
Then over here are a lot of craft supplies.
3 sewing machines. I got a regular sewing machine, Lemore's serger, and a cover stitch machine. This is Inez. I've had her since I was like 13 or so. She's adjustable. This dress form belongs to Lemore, so I can't name her.
Over here we have some bins of different materials, conductive materials, felting supplies, ribbons, hot glue, Velcro, and the safety supplies.
These are our video hard drives. I've got an 8 terabyte and a 4 terabyte, filling up fast.
On the back of my desk, there's a new feature. I just put in this cord organizing rack. Ooh, so organized. And then on the back of my desk, I like to have some business cards and some projects.
Thanks for coming with me to check out my desk. We'll have more wearables projects coming to you soon, so don't forget to subscribe to our channel here on YouTube.
Becky Cam.
Okay, so don't forget, Wearable Electronics with Becky Stern, not on next week, so it'll be 2 weeks from now. We had a show today. You can watch it on YouTube. Next week, we're off, and then the week after that, Wearable Electronics with Becky Stern returns. Okay, 3D printing. This week we have a video. This is, drones are really popular. I saw the Lily.camera drone video this morning. It's pretty impressive. One of the things I think people are going to need, they're going to be able to need to 3D print drone parts, and this video is a little bit about that, so let's watch it.
Coming up, we're testing drones. We're crashing drones to test them, because we have to. It's our job. Okay, so this week we're 3D printing drone prop guards, and we thought it'd be a really nice way to test out some high-strength materials. You guys know there's a lot of different materials out there, so we thought we'd try a few of them and just see how they perform. So here we have ABS, carbon fiber, XT copolyester, and T-glaze. They're all different types of material, but they're all high-strength materials. We're actually going to exclude PLA from this because it's pretty brittle. Becky actually tested this one out on her Iris, and it didn't hold up so well. Pretty brittle. So we're comparing strength, rigidity, and weight. Weight is pretty much the important factor here considering you get reduced flight time. The goal here is to test how well these filaments perform, so we're pretty much crashing drones. First, let's take a look at Pedro's prop guard design. It started out as a really cool wing type guard that clips onto the arms, but now it's sort of more simple, a lot more easy to install, pretty much optimized for flight time. It's about 2 millimeters thick, so it's going to perform pretty well. They just snap onto the motors and they're held in place with a tight tolerance. There's a little chamfer on the edge too, so it's a lot easier to install. The file is up on the Adafruit Learning System, so you can download and modify the design if you want it to fit it to your drone or your project. Let's take a look at the weight of these printed in all 4 filaments. Out of the bunch, we can see ABS comes in at the lightest. We kind of expected carbon fiber to weigh lighter here. First up, we're testing carbon fiber, which actually prints a lot like PLA, so no heated bed required. You can print with your average extruder temperatures of 220 to 230 C. The 4 prop guards printed in carbon fiber weighs in at just 3.3 grams, which is a bit more than we expected. So these feel a lot stiffer and there's not much flex to these. The tolerances for the clip are actually a little bit more loose than we'd like, so it could probably cause problems when testing. I'm sure a small bump might move these out of place. So for testing, we'll start off by slowly bumping into walls, and well, right off the bat we had a major crash and actually broke one of the prop guards. This one is unfortunately one of the easiest to break. It's shattered into pieces, so it's definitely brittle and feels a lot like PLA. Okay, next up we're switching to T-glaze, which is a blend of PET. This one does require a heated bed, and it's actually a little bit more difficult to print. There's a little bit of layer adhesion problems, so you'll need to slow down your print speeds so it doesn't warp, because it kind of did. You can see in the B-roll. The T-glaze guards weigh in at just 2.9 grams, which is a little bit lighter than carbon fiber. It does have a bit of flex to it, and it actually grips onto the motors better. The first couple of bumps held up pretty good, but we did manage to break a guard. The weak point here is a little bit different, so you can see where it breaks. Next up, it's XT. This one is a lot easier to print since it doesn't require a heated bed, and the extruder temperatures you need a little bit higher, somewhere around 240 to 250 C. Very minor warping and layer adhesion problems, so it's actually a lot safer to print at a bit faster rate. For the weight, it does come in at 3.3 grams, which is about the same as carbon fiber. This one also has a little bit of flex to it, and it grips pretty good to the motors. We're pretty surprised how well this held up on head-on collisions. There's a bit of flex. I think it really helps the guards to be resistant to shocks and impacts. We kept testing head-on crashes, and it didn't break any of the guards, which is pretty amazing. The only thing is that they're a little bit heavier though. Okay, now we're going to test out ABS, which does require a heated bed, so it takes longer to print because you got to heat the bed and let it cool down. ABS weighs significantly lighter than the bunch, coming in at just 2.6 grams. It also has nice flex to it and feels a lot softer than the others. Tolerances are really tight, so they're going to grip onto the motors nicely. On first liftoff, we can really feel the weight difference here. It's a lot lighter. The ABS guards held up during all the bumps and head-on collisions. This stuff is really tough and didn't break. It's a lot lighter, it has that bit of flex, so it's pretty darn strong. It does require a heated bed, so it's a little bit harder to print depending on your setup, but it works really well as prop guards. So there you have it, testing materials based on strength and weight. ABS and XT definitely perform really well. They both are pretty shock resistant and they have that bit of flex to it. When it comes to weight though, ABS does come in lighter. The only tough part about printing with ABS is of course the heated bed. We tried these filaments on this week's project because that's kind of what we had on hand, but you can let us know what type of filament you'd like us to try next. To print all of these prop guards, we use the Orion Delta 3D printer from CME CNC. It's a pretty good high quality Delta bot which has a heated bed so it can print all sorts of different materials like the ones we did today. We have it in the Adafruit shop so you can check that out, and you can also check out our video review here if you haven't already. So there you have it, crashing drones to test high strength materials. A lot of fun. I hope this helps you guys out if you're thinking about printing your parts in high strength materials. All right, so that's about it for this one. Now we're gonna go ahead and try to fly around the studio and see if we can land on these build plates. Thank you guys for watching, and we'll see you in the next one.
Okay, and don't forget tomorrow, 3D Hangouts with Noah and Pedro. Be sure to watch the show every Thursday at 3 p.m. Okay, lady, it is time. We are going to do the code. It's Flora, 10% off in the Adafruit store, all the way up to 11:59 p.m. Eastern Standard Time tonight.
Okay.
Let's get to new products. It's time.
It's that time. I know, we have a lot, but we're going to get to it.
Okay, I'll start the first one. This is a sticker because we're doing a pack. It's an Astro Print sticker. I don't need to talk about it more than that. It's a sticker. Okay, we got some servos.
This is a new continuous rotation servo. We've actually carried a Futaba continuous rotation servo, but we actually like this one a little bit more. It comes with more horns, and it's continuous rotation. Can you go to the overhead and I'll just shut off. It rotates all the way around, so it's good for wheels, and it's pretty big, so it can, I'll put this one away, so it can really drive like a large wheel. We also have micro continuous rotation servos. These are bigger, and yeah, it comes with like all the different attachment things, like the Futaba one didn't, and also this one's a little bit less expensive because we're buying it direct. And it's got this, if you have to adjust it, there's this little hole here, you can adjust the 0 point. So it's got everything you'd want from a continuous rotation servo. That's it. It's basically an updated product.
Gotta keep moving, moving. Tubes, we got tubes.
Tubes! You want tubes? I got tubes. These are our tubes for our professional solder sucker from Engineer. And like the very friendly people Engineer are like, you should carry the tubes. And we're like, fine. So we just got like 100 sets of tubes. I mean, people have been asking for them, so it's good. If the tubes gets melted or damaged, you just cut another piece off and stick it onto your solder sucker. And huzzah, you now have a new fancy solder sucker.
Yeah. Oh, quick question. Is that servo metal geared?
No, this is a plastic geared servo. But it's got pretty good torque. So, I mean, like for a gigantic robot, you probably want to use a DC metal geared DC motor. But this is fine for like small robots that are like, half a pound or so.
Okay. And because we have some Internet of Things stuff going on, Nimbus, the friendly cloud entity, is here. I'm totally okay with all this data. Totally okay.
I love this data.
Anyways, the Netduino 3 Wi-Fi is out. This is a monster board.
Yes, this is
a lot going on.
This is the Netduino 3, which uses the CC 3100 module, I think. Yeah, it uses a 3100 module, which is the next generation after the 3000, and it's basically an SPI Wi-Fi module. And this is, basically Netduino. It has that .NET infrastructure. You can program it if you're like a Windows person or Microsoft person. You like .NET. This kind of lets you mix the joy of doing Arduino-like things with the joy of .NET, and it has Wi-Fi, and I guess there's libraries and stuff to make it pretty easy. There's all that micro SD socket over there, power plug, big ARM chip in the middle, I guess for the STM processor. you're rocking out. People like Arduino, we have the latest.
Okay, next up, really big news. So, real quick, if any of you have one of the big carriers like AT&T or T-Mobile or Verizon or Sprint, you know it's a very big challenge to really have good service from them. And also, if you want to do things with electronics, machine to machine, if you just wanted to pick up a SIM card and do pay-as-you-go, if you wanted to have a dashboard, a very easy thing to look at, how much data you're using because you're doing all these types of Internet of Things projects, there wasn't a carrier out there. So, big news, Adafruit is now a provider of Ting SIM cards. And Ting is probably one of, and ask around. Anyone who has Ting, they're like, oh my God, it changed my life. So for phone service, just straight up phone service and data for all phones, they're great. But you can also get a SIM card from them. And we have, and this is what we're doing. So we're putting the SIM cards in the store, and we have to charge for the SIM cards, and then you have to activate them. But just one quick thing I wanted to show before you go into your thing. This is how the dashboard that you can get, and you can look at it in all your different devices, and you can see how much data you're using. It's pay as you go. Go to their website ting.com and see how they do stuff. But I'll toss it back to you, Lydia.
Yes.
But what are the things that you like about this?
Well, this is a true GSM 2G SIM card. So we do have a 3G module that will be coming out in the next few months, but it's going to be much more expensive than 2G. And for a lot of people, if they're in a T-Mobile area and T-Mobile doesn't have any plans to shut down their GSM, and I think it'll be around for quite a while. There's millions of devices that use 2G. This is a very inexpensive and easy way to get your phone a project going. So it comes as a big SIM, and you can pop out you have the standard huge SIM, and then like the kind of standard mini SIM, and then there's the micro and the nano SIM. So you can use this with any device this is a SIM card. You can use this with any device if you have like something that needs cellular GSM. And you can activate it on their website, very easy, and it's pay as you go. And you don't have a gigantic like monthly thing. You just pay depending on how much you use, you just pay a little bit more. So it's much less expensive, and there's no like crazy maintenance thing. Like one thing that annoyed me about like T-Mobile is they're like, you have to give them $30 a month. And with these people, there isn't. They just like bill your card, but it's only like $6, and then
here's
very
the
easy
other cool
to
thing.
use.
If you kind of grew up on the internet like a lot of us did, these are the folks who started Two Cows.
That's right.
So
if you remember Two Cows,
they've been
TU
around.
Cows.
Yeah, they've been around for a long time. Okay.
So, anyways, this is it. So people have been asking, like, hey, Adafruit, why don't you carry a SIM that works with the Fona? And this is a guaranteed. We actually test each Fona with one of these SIMs. It's this one, Ting number 4. This is what we use to actually test each Fona, so we know for a fact that it works, and it works really well. It works used as a T-Mobile network, so make sure you have T-Mobile service in your area. Other than that, it's pretty straightforward. It's only for use in the United States. We're only our zone is only for USA. But if you look at the Fona tutorial, we have links to suggestions on where to get. You can actually like pick up a SIM card so easily in Europe that I'm not too concerned about.
Okay. Next up, choo-choo, all aboard the learning train. So this is something we're working on. This is the Adafruit learning map, and we're playing around with this idea where you would learn based on like a train map. So this is Blinky LED Boulevard, Switch and Button Street, Analog Input Alley. Watch out for that one. Pulse Width Modulator Place. And you can see that you can progress through the map and learn different things. And this is all part of our Metro. This is one of our new products, and this is a different one than you saw a couple weeks ago. This is Metro with headers. And so what's the difference now?
We had Metro without headers, which is like basically just a super slim version. Sometimes you don't want headers attached for some reason, like you want it to be super skinny, or you want it to like attach wires to the points and solder them permanently. But this version has headers, and they have surface mount headers. Can you show them the overhead?
Yeah.
And this is an Atmega 328 processor running at 16 megahertz. I'll pick my notes. I'll zoom in. It's got the Atmega 328, and it's got an FTDI chip, which I really like, connected to a micro USB port. And then over here, here, I'll just actually plug this in so I can sort of see it rocking out. It has a on-off switch even for if you're using DC power, which I don't have, but you can sort of see there's a green LED, but you can turn it on and off if you'd like. There's an on-off switch. You can change the I/O level from 5 volt to 3 volt. Which is handy if you're trying to use this. Normally it's 5 volt logic, but if you want to use it with 3 volt chips. And all the headers are surface mounted on, but they're very strong, so you can like attach shields as normal.
Yeah.
right on top. Hold on.
And I have.
I had like one bent pin, so I have to just adjust for it. But just, you make a little shield sandwich. Works with all the Adafruit shields. And it's just, it's super easy to use. It has the OptiBoot bootloader. So if you're using this with the Arduino IDE, just select Uno, or if you use our board, it shows up as Metro, if our board package. Other than that, it's just kind of like a very easy, kind of hacker-friendly Atmega 328 dev board. I put the LEDs on the edge because I'm always like trying to peek in. Like if you have the shield on top, like it's hard to see the LEDs, but like now it isn't because the shield's over here. I'm like, oh yeah, look, I can see the LEDs, yay! So let me see if I can find a power switch.
You got like a bunch.
Yeah, here's one. So for example, yeah, you have a power switch in and then you can turn it off. So I kind of like that because one thing I always miss from electronics is having an on-off switch. So that's kind of one of the things I liked adding.
Okay, moving right along, we got more.
And it's like so smooth. Metro.
Yeah, so here we are.
It's like a Metro card.
Yeah, and there's the back. And we liked a lot.
Yay.
Okay. Next up, the Flora Bluefruit LE. It is here. This is a wearable Bluetooth device. This is one of the few out there that anyone's ever made, and we're really happy with it because we have all this stuff that we built in advance, including our iPhone and iPad app. So I'll show this just to make sure you can see the video. It repeats itself, and then we'll go to the overhead and you can do a live demo.
I'd like to do a live demo. I think I can do this thing.
You can handle the live demo?
I can do it.
Okay, so this is what it looks like when everything's working out. But then we'll also
Here's what it works out.
yeah, we'll also get a live demo too.
Okay, so let me zoom back out. So here I have a Flora, and I have that Bluefruit low energy, and then I have a NeoPixel connected here. I don't know if you can read, but I can connect to the Flora Bluefruit, and I'm going to connect in controller mode. And there's a whole bunch of different modes that you can use this in, but controller kind of lets you do like data passing back and forth. Come on, pair. All right. And then I can do stuff like send data from the iPad, like quaternion, accelerometer, gyro, magnetometer, and location data, like the GPS from within the phone to the Flora. So if you want to add like these sensors to your wearable, you can just use the sensor inside your phone and then pair it, and then you send the data from the phone. So when you move the phone, it has that data transfer. But I'm actually just going to go to the color picker, which is the kind of simplest demo. And whenever I send, I click, whoa. Oh my God, it's not working. There you go. Sorry. I have to click. You have to actually press the send button. That's the secret. The LED matches the color that I'm clicking. So, I can, it's basically just a simple demo of changing colors. But you can see how, okay, if you want to make some sort of interactive wearable project, and you want the colors to match something else, instead of having a color sensor, you can just open up your phone and get the color picker out and pick your colors. So that's just the demo. And we have a lot of examples from using this as like a heart rate monitor, like it's a standard Bluetooth type, to just sending data back and forth, to the color picker, to a controller, to just like turning it into an iBeacon, like all sorts of fun stuff you can do with Bluetooth energy. And it's super easy to sew on just for wires or threads. Yeah. And you're Bluetoothing it. So this is definitely, I think, the first sewable Bluetooth low energy device in the maker market, so that'd be cool.
Okay.
People use it.
Yep.
Do something fun.
Now I think
this demo's gone. Bye demo.
Yeah, and I think tonight the star of the show besides you, and why the code was Flora, is we're pleased to announce the next version of Flora is shipping.
Wow.
Ta-da!
It's Flora 2.
That's right. So Flora 2 is here. It's I'd say probably one of the most
loved.
Well, I've just seen a ton of projects with it. We really wanted to focus on wearables a couple of years ago to kind of kickstart all the things that were going on that we wanted to see, and we have a couple changes. The biggest notable one is there's a NeoPixel on it, and the other one is the micro USB. Mm-hmm. Why is that right? Did I guess?
Yeah, there's basically two essential changes that I made. One is we are slowly migrating all of our designs from mini USB to micro USB. Even though micro USB is a little bit more a pain to pick in place, we found a good package that we like, and it's really nice and strong. And so we're using all the new devices. We're moving from mini USB to micro USB because it's just becoming a standard. Everyone has micro USB cables. The connector's a little bit more durable. So this, Pro Trinket, we did micro USB. Metro is micro USB. And so we finally got to the point where it's like, okay, we've sold through the Floras. It's time to do a revision. So I revised the mini USB jack to a micro USB. And that made it a lot smaller. And it pushed it up. And so there's a big space that wasn't needed anymore because the mini B jack was so big. So I moved all the components up. And that made a little gap that was exactly like NeoPixel sized right above the button. And I was like, I wonder what I can put here that's like kind of like in size of a NeoPixel. I talked to Phil, Mr. Lady Ada, and like we had like meetings, like round tables. Yeah, we had a whiteboard, and we're like, what could we put there that's kind of like NeoPixel sized? and then eventually we had this brilliant idea that we just put a NeoPixel on there. And so we stuck a WS28112S on there. With the resistor, so you can use it from a wide range of voltage from like 3 volts, and we tested it up to like 7 or 8 volts, and it's just fine because it's a voltage drop through the resistor. And we just got this fancy glowy LED that is just using one of the pins that isn't brought out. So you pin 8, you can connect a NeoPixel. So this is really good if you want to have some like feedback immediately about your project without having to like sew NeoPixels. This gets you started really, really fast.
Okay. Congratulations, you got through it.
But otherwise, it's the same size, same code, same processor, same speed, same voltage, same everything.
But the two big differences are?
Micro USB jack,
yeah,
NeoPixel on board.
Okay. And that was new products tonight, folks. Boom. Okay, the code is Flora. Anything you see that we have in stock, code Flora, 10% off all the way up.
Including Floras.
Including Floras, all the way up to 11:59 p.m. Eastern Standard
Time.
Yeah,
I got the Flora glowing, but you can't see it.
Well, you had it over the overhead.
No, I didn't get to show them the overhead.
Oh, you want to see?
Maybe while people are getting their questions, yeah.
All right, well, we're going to go to questions, so start typing your questions.
You can look at this
in the chat.
Glowing pixel.
And we'll get to those. Let's start it off. First up, so for micro USB connectors, what do you look for to make a strong, get a good connector? Because, there's been crummy ones. So how do you make sure it doesn't because you always make me do the man test. Like if I can rip it off the board, you're like, oh, this isn't good enough. So these are really strong. How did you find these?
Yeah, so I actually went through like 3 or 4 different packages. So one thing is the fully surface mount ones you cannot do on maker projects because the ones that have the surface mount pads, because those are designed for if it's in a case. Like in a like a tablet case, and there's like metal surrounding it to keep it in place. If it's just surface mount and you yank, it'll just rip right off. The mini Bs won't. They're pretty strong because the pads are really, really big, because like the package is huge. But micro USBs will not survive a tearing. They'll just rip off. It's not going to work. So what you have to do is you have to get ones that have the through-hole legs. And I even found that ones that have 2 through-hole legs aren't that strong. So the ones that I use have 4 through-hole legs. And so if you go to the overhead, I'll show you the through-hole legs.
This is like a serious answer.
Yeah, so you see these pads here. Those are actually slots, and then these are 2 holes. And then when we paste it, we put a ton of paste on those pads. And so there's paste underneath the connector that keeps the connector flat against the PCB. And also there's these pads and slots are full of paste, and they melt and they hold it down. And so like you can do the man test on this if you want. But like it does not come off. Like you can really, I don't want to break it because I'm stronger than I think or something, but it's not going to come off. And another thing that's good about micro USB jacks, if they are the good kind of jack, is that the cable has the retention clip in it, so you don't have to worry about like the micro USB doesn't wear out. It's the cable that wears out, not the jack. So it took me a while to find a good connector. Like we tried surface mount ones and they just kept tearing off. And then when we finally figured out like this is the correct connector with the 4 through-hole legs,
okay,
it's changed everything. So everything's now micro USB.
Okay, we're gonna speed round through some of these things. I read somewhere that the ESP8266 is somehow asynchronous. Can you explain what that means in context of Arduino code? Anything to watch out for programming the Huzzah?
I don't know what they meant by asynchronous. I do know that there is a watchdog timer, and so like you can't have a loop like without the code. There has to be this like little bit of code that kind of pings the Wi-Fi chip and just kind of makes sure that the watchdog knows that it's not hung, and it has like a built-in watchdog detector. I don't know if that's what it is, but also like when you write the code, like you send data and then the reply comes in later. Okay. So that might be what they meant by asynchronous. Okay. I don't know where you read it.
Can the Bluefruit BLE friend be used as a standalone unit without the need of an external microcontroller?
It can. We have like a couple of the demos. It can do standalone, like the iBeacon or the Uri beacon, or can act as a standalone. The thing is that we have firmware on it that does a lot of stuff. So right now, those are like the only two things that it can do standalone. You can turn it on, and then from the app side, like query things, like through AT commands. Kind of, it's not really well documented, and also we don't have a version that has all like the pins brought out, so it doesn't matter. If you're good at programming, you can connect a J-Link SWD programmer to the 2 pins on the back and just program the chip using Nordics SDK. And then you get a Cortex M0 with Bluetooth Low Energy, but we don't have a code base for that. You'd have to use Nordics. It's their code.
Okay, so next up, this one might be hard. Does the beacon sketch for the NRF 51822 do iBeacon and Android physical web?
That's a good question. We have one for each. We have an iBeacon example and a Uri beacon, which is the physical web beacon.
Okay.
Right now, we think Apple changed something with iBeacon. We don't know because we aren't willing to sign NDA.
It sounds like something to do.
Yeah, so they love changing stuff. So the iBeacon example may or may not work. We have to kind of like figure out what may have changed. Like they have specific timing. They got like people kind of like made iBeacons and then they kind of narrowed down what is acceptable. And so we have to go reverse engineer it all over again and find official iBeacons. But with physical web beacon example works great. And it's like a URL, like you just program in your URL.
Okay. Can the Bluefruit update code on the Flora? The person wants to change the patterns on their Mickey Mouse using a phone.
What you can do is I wouldn't.
You'd want to look at Phil's tutorial, right?
Well, you can do Phil's tutorial. So we have the color picker. But the other thing we've got, so what you would do is you wouldn't reprogram the Flora, but the Flora, we have an example for Flora where it can read stuff. So like you would use either the color picker, which you can kind of see, so you could pick colors, or you could use the control pad, which just gives you sort of like a basic, like, okay, you can just like press buttons, and so like, oh, faster or slower, like pattern A, B, C, D, or something like that. You could do that, and then on the Flora, it would listen for that message. Like when you press the button, it can hear that message, and then it would change the pattern. So you're not reprogramming the Flora. You would write the Flora to listen for the messages from your phone.
Okay, can Bluefruit send text to a serial display using another microcontroller? We send text using our app to our hat.
It can send text to a serial display. No, because right now Bluetooth Low Energy cannot do mesh networking. So you can send data from the Bluefruit to a phone or computer and back, but you cannot send data from a Bluefruit to a Bluefruit. You'd want to use something like an XP for that. It just that is not part of like the Bluetooth specification. It doesn't let you do that. You can only send it from like a central, like your phone or your tablet or computer, if you have like a Mac computer or sometimes Linux, to the Bluefruit, but it can't act as a master or a mesh controller.
Okay.
So for that, you'd use XPs.
All right, that was a speed round. Whew. Thank you, lady. That was questions. All right.
Okay.
Trivia question tonight. We're going to give away a Flora. And what are the rules?
Rules are, if you've won something from this show before, Ask Engineer, you're the one that see this little bubble. If you've seen that while you've won something, you can't win again. Only one winner per my lifetime. So like sit on your hands or like just go get a sandwich or pet your cat or something. The first person to answer correctly in the YouTube or Ustream chat, whichever we see first, is the winner of a fabulous Flora 2. You get a Flora 2. That's the rules, really. That's the only rules.
Here is a trivia question. First person I see who types this in, and it is a one-part question. What type of USB connector does the new Flora have? The one that we just released today. Flora 2 has a new type of USB connector. What type does it have? Let's see who gets it first. 40 pin is not the right answer. A good try.
It's a lot of pins.
A lot of pins. Let's see who gets it. Waiting. All right. Looks like Asa McQueen. Congratulations, Asa McQueen. It's a tight one. Looks like there's two people almost at the same time, but I saw So first, I'm gonna post
McQueen.
Yeah, Asa McQueen. Please email support@adafruit.com, and we will send you out a Flora too.
Congratulations.
Congratulations, you get a
Flora.
bonk. There you go. All right, that's it for the week. We're a little running over time a little bit, but that's okay. That was the show. Good work, you. You did a good job.
There was a lot of flooring.
That was it.
Sewing. Sewing occurred.
Yeah. If you want the prize, email support@adafruit.com and just tell them you want a new Flora, and they'll be able to help you out.
Yeah. We don't have any old floors left.
There's
so.
no more. We sold through.
We sold.
Okay. So with all that being said, that's the show this week, Lady Anna. We're going to be here next week.
That's right.
Every week we do this. Wednesday night, 7:30 p.m. is Show and Tell. Wednesdays at 8 p.m. This is Ask an Engineer. The code is Flora all the way up to 11:59 p.m. Eastern Standard Time tonight.
Oh no, I dropped all the paper.
Please get on it.
Sorry.
And then, where'd you go? She's gone.
Sorry, everything's gone.
And thank you everybody out there for supporting us. We don't do advertising. We don't have sponsors. We don't have bank loans. We don't have venture capital.
We don't have a Kickstarter.
We don't have a Kickstarter. We are only supported by people picking up hardware and telling other people if they like it. So thank you so much, everyone. You're the reason we're here every week, and thanks for sticking around. It was an hour.
We're not going to be at a Maker Faire.
We're not going to be at Maker Faire. A lot of our friends, family, code products will be there. We're sticking around here.
We're
in New
there in
York.
spirit.
Yeah, we're releasing 6 or 7 new products this week, so it's hard for us to do cross-country stuff. I did my Maker Faire time. I was there in the beginning.
We did a little video for the 10th anniversary.
We did a video for the 10th anniversary. Also, happy birthday, Dale, if you're watching.
Is it Dale's birthday?
Yeah.
Wow,
and
cake.
Also, Maker Faire is 10. So we'll be there in spirit. Lady and I have to run a factory, so it's hard for us to leave.
How are we going to make all these goodies if we're not here?
Yeah, we have to make sure all the makers get their NeoPixels.
Okay.
So we'll see everybody next week. We have a picture of a cat. And here is your moment of Zener.